We know that sets are very important in learning real analysis, but only the concepts and ideas of sets will they help us to solve the problems? Will they help us to understand the complex proofs which we are yet to prove in real analysis? Certainly not. Only the sets and ideas are good to start, but now it is the right time that we should understand how do we do the operations and different type of areas of mathematics that helps us with sets, and these sets will help us to learn and understand the problems of real analysis. Let us understand that real analysis deals with real numbers, and these numbers are divided into certain groups, and these groups will be only the sets will help us to solve these groups. So we are learning sets in order to make things easier. Welcome to the third lesson in freshman course in real analysis. My name is Shaunak and you're watching this video on my channel Physics for Students, and in today's video we will like to go a little bit deep and want to learn that what are the operations of sets with certain very simple examples so that things become very clear. So as because in arithmetic we start with addition, multiplication, etc. So first we will start with addition, which is called the sets language union. Okay, so what is a union? So if we take two sets A and B, then the set consisting of objects which belong to A or to B or to both is called the union of the sets A and B. So the union is denoted by the symbol. Simple, we call it union, so that is why it is a U. So if we can write it in this set builder format, A union of B is this, or X is an element of B, or X is an element obviously of both A and B. Otherwise, how will the new union happen? So we have taken an example 1, 3, 5, 7, 9 and Q equals to 2, 3, 5, 7. So obviously the union of P and Q would be addition of all. So we will take all the elements of P and Q and its result to 1, 2, 3, 5, 7 and 9. So this is a kind of a schematic diagram of what is called a union. So two sets are joining with each other. Okay, once we are done with union, obviously the second thing which comes is some kind of a subtraction. It is called an intersection. So what is an intersection? So the set consisting of elements which belongs to one set A as well as B, it is called the intersection of A and B, and it is denoted by this. So it is just the opposite of U. Let us take an example. This is again in a set builders format. So we can write X is an element of A and X is an element of B. So for example, we have taken the same 1, 3, 5, 7 and 9 and Q equals to 2, 3, 5, 7. Then P intersection of V would be only the common elements of P and Q. So 3 and 3, 5 and 5, 7 and 7. We have discarded 1 and 9 because we are taking the intersection. That means we will take the common factors. So the intersection of sets is a set of elements which are common to the given set. So something which is common to P and something which is common to Q. In set theory, for any two sets A and B, the intersection is defined as the set of all the elements in set A that are also present in set B. So remember, those sets or elements which are only present in A are also present in Q. Those are called intersection. Okay, now that we have known union, intersection, the next point, okay, this is a schematic diagram which shows the intersection, only the red zone, that is which is common in both of these circles. Okay, now something which is called the disjoint of sets. You can understand that it is a kind of an arithmetical formula that we are going addition and then subtraction, and this is something called a disjoint. Okay, so what is a disjoint of sets? So two sets A and B which have no common elements, right? It is called a disjoint. So A intersection of B is a phi. That means it's a null set. Then A and B are called disjoint sets. Here is an example. I have taken 2, 3, 5, 9 and 1, 4, 6 and 12. So A intersection of B equals to 2, 3, 5, 9 in this and 1, 4, 6, 7, 6, 12. So no element is common in A and B, so that is why equals to phi. Therefore A and B are called disjoint sets. Here is an example. You see on the A it is 1, 2, 3 and this is 5, 7 and 9. Okay, now we come to something very important which is called subsets, set, subset. Now set, subsets will have further other forms and formula which we will look one by one. Now what is a subset? Now I have taken an example. If I take a natural number, say a set A which has got 1, 2, 3, 4 up to 10, and set B which is the odd number from 1 to 10, that means 1, 3, 5 and 7 etc. Then B is the subset of A. Yep. Why? Because the intersection of, because B is the prime numbers, which is a subset of A, which are the whole natural numbers. So we write it something as A intersection of B is a subset of A, and A intersection of B is also a subset of B. Say, for example, if I take 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And I have taken 2, 4, 7, 12, then A subset of B would be 2, because here 2 is present, again 4 is present, again 7 is present. Rest of the thing that we are discarding, and this is how it looks like. So all those which are present in the bigger set 1, 2, 3, 4, 5, you will see A set will only have 1, 2 and 4. Okay, I think this part is quite clear. That means that those sets which are I would say in the B, we have taken the subset of A intersection of B. That means we are just taking 2 which is in this both, 4 again which is in both, and 7 which is in both. But you see we are discarding 12, 15, 1, 2, 3. These are not included, they are subsets. Okay, some of the important properties of subsets. What are those? Say for example, if we say an element of set A or in another set B, for example, it is present, then set A is said to be a subset of set B. That means A is a subset of B, or B is a superset of A. Don't worry what is a superset, I will be coming to that. Okay, so if I take a kind of an example, for example, A is the set of natural numbers again, and B is the set of whole numbers, obviously then A is a subset of B, because all natural numbers are automatically present in the set of whole numbers. So here you see, for example, A is 1 to 3 is a subset of B, because B also contains 1 to 3 as well as 4 and 10. So if I take again example A equals to PQR, and then it is a subset of B, and B contains from A to Z all the alphabets. So it is quite clear. These are 2 of the properties of subsets. Okay, now we need to calculate what are the number of subsets of a set. What do I mean by that, coming up in this part of the video. Now whenever we are going to calculate, there is a formula. The formula is the number of subsets. If you want to calculate of a set, it is just 2 to the power n. So if I get 3, 1, 2, 3, then the elements would be how much? A equals to 3, right? So I get 1, 2, 3, 4, 5, 6, 7, 8. That means 2 to the power 3. I will just count the number of elements multiplied by with the number of elements 2 to the power that. That means, yeah, it has got a total of 8. So 8 equals to 2 cube. So if I get 2 square equals to 4, that means there will be 2 subsets. If I get 2 to the power 5, 32, that means it will have 5 sets. Whatever be the power, that will be the number of elements. I am going to say number of elements. So the number of subset is a set with the n number of elements. Whatever be the number of elements, you have to put it on the power, and then you have to take it as 2, right? Okay, and if I get 2 to the power 0, what would be it? Obviously it will have 0 element, because it will cancel out, and this will be 5, that is a null set. Okay, now there are 2 types of subset symbols. I would like to take a pause and tell the viewers that, see, I will be making the next video on the different confusions of symbols, because some books say this kind of a symbol, some books say this kind of symbol, but right now I would be telling that the 2 types of subset symbols which are used. This one is basically read as is a subset or equal to. So you see a line at the bottom, that means it is a subset or equal to, or you can just say it is a subset of A and B. So for example, if I take this one, is a subset of B, right? And there is this symbol which doesn't have a line at the bottom, and this is basically called is a subset. Means it's strictly a subset of, but not equal to. I will come to the later what I mean by equal to, but let us understand that a bottom line means it is equal to, it is a subset. The second one is also a subset, but it is not equal to, and we write is as A is a subset of B. Now there is something which is called a propersubset, which we use this symbol, and this is called an improper subset, which we use this symbol. Also the same thing. I will just explain in this video what is a proper subset and what is an improper subset, but these are the 2 symbols of subset. Okay, we know that these are subsets of something. How do we denote if it is not a subset? So for a not a subset, simple, if P equals to 1, 3, 4 and Q equals to 2, 3, 5, 4, 5, 6, obviously P is not a subset of Q, and we denote it with this diagonal arrow, right? Since it has elements 2, 5 and 6 which is not present in the parent set. Let us see another example. A equals to 3, 5, 7 and B equals to 1, 4, 5, 7 and 9. So what happens is that A is not a subset of B. The reason is that 3 is an element of A, but somehow it is not present in B. So that is why A is not a subset of B. You see 3, 5, 7. So 5 and 7 is there. 1, 4, 9, but 3 is not there. 3 is present only here. So 3 is an element of A, but it is not an element of B. So definitely we cannot call A is a subset of B, because for A it has to be 3, 5, 7, then it has to include 5, 7 and also 3, then it will become a subset, right? So here is another schematic diagram which shows that if I get 1, 2, 3, 4, 5, 6 these numbers, then this is the subset, which is the one this common 3 and 4. Okay. Now we will understand what is a proper subset and what is a not proper subset. We have understood what is a subset and what is a not a subset. What do we mean by a proper subset? Very simple. See, let A be a set. Now, is every element of A in A, that for example A contains 3 oranges, then if I ask you where every element of A is in A, well, you might say yes. Now the question is that means that A is a subset of A. That means it is a subset of itself. Well, you can say, well, but I mean to say it really doesn't sound very solid, right? So that this doesn't mean seem that it would be something very proper. So we want our subsets to be proper, and we introduce this syntax, proper subsets. So here is the very simple definition. A is a proper subset of B, and only if every element of A, say 1, 2, 3, 4, I will show you an example, is also in B, but there exists at least one element of B that is not in A. Now, for example, let us see. This is important to make sure that A is not a proper subset of itself. We may say that B must have at least one extra element. That means A is also in B. That means all the elements will be there, but at least one element in B which is not present in the parent subset A. Say, for example, 1, 2, 3 is a subset of 1, 2, 3. We just saw it. Now 1, 2, 3 is also, so we denote is like this, like a subset of this. Now, but it is not a proper subset of 1, 2, 3. Why? Because 1, 2, 3 and 1, 2, 3 both are common. And we have seen in the previous definition that B should have one extra element which is not in A. So we write it as this. 1, 2, 3 is not a proper subset of this. However, 1, 2, 3 is definitely a proper subset of 1, 2, 3, 4. Why? Because B, this second one, has got an extra element 4. And because this is not in the first set, and this is how we write it. Proper subset, right? And when we say that A is a subset of B, we write it in this way, and subset or subset equal to, and this is something which we tell that A is not a subset of B. Now you might find something very confusing. Why you're using this as a subset? Then again we are saying it is a proper subset. I will come to that. Some symbols are used in exchange manner, so it seems to be so. I will come to the symbols. Okay. Now how do we calculate a proper subset? Given a subset, a set, how do we calculate a proper subset? It is simple. We will take n minus 2 to the power n minus 1. Now since all the subsets, remember, of a set except the set itself is basically proper subset, hence the number is subtracting from 1. So if A equals to 1, 2, 3, the number of proper sets would be 2 raised to the power 3 minus 1. That will be 3 minus 1 would be 2. I'm so sorry. It would be 4. Right. Now if I take A and B, the number of subsets would be this one. 2 minus 1 and the raised to the power 1. Right. Okay. So if you take the number of proper subsets as phi, and if this one goes on, then this would be equals to 0. Right. That is how it actually happens. Right. Okay. So what are improper subsets? There is something which is called an improper subset. Now, improper subset is a subset which is not a proper subset. That is, every set has only one improper subset. It's very easy to understand. So 1, 2, 3 is the only improper subset of 1, 2, 3. AB is the only improper subset of AB. Very simple. And for writing the improper subset, we use this symbol also. If A is an improper subset of B, then we write it in this way. And what is the rule? Simple. The number of improper subsets of a set with n elements is always 1. That means the number of improper subset of a set does not depend on the number of elements. Whatever be the number of elements, the number of improper subset of a set with n elements will always be 1. Okay, so we now come to the final set concept, which is called a superset, which is pretty simple. A superset is a set that contains all the elements of another set, which is called the subset. So in ordinary language, if I say if B lies inside A, then obviously it means that A is the mother which contains B. In other words, B is a subset of A, then A is the superset of B. How do we symbolize? This is one. We say that A is a superset of B. Say for example, A equals to A, B, C, D, E, F, G and B equals to A, B, C, D. Then we say that A is a superset of B. Why? Because all the elements of both of them are there. And yeah, A is a superset of B, and B is a subset of A. Yeah, obviously, because you see the elements of B are in there, so B can obviously be a subset of A. So since the elements A, B, C, D are in the set A plus the elements E, F, G, that means A contains A, B, C, D, B contains A, B, C, D. If that would have been so, it is not a superset. It should have some extra elements, that is E, F, G, and hence A is the superset of B. So this is a kind of a schematic diagram which shows A is the superset of B. Okay, what is not a superset? Simple. If A equals to 1, 2, 3, 4 and B equals to 1, 3, 4, then A is a superset of B, but B is not a superset of A. Why? Because the reason is that just a second. The reason is that B has got 1, 3, 4 and B is not a superset of A, yeah, because A has got 1, 3, 4 and another element which B has not got, that 2, 1. So that is why B is not a superset of A. Okay, what is a proper superset and not a proper superset? It will be the same as normal superset. So the proper superset is also known as strict superset, right? We will come to this later. The set B is the proper superset of A, then all the elements of set A are in B, but set B must contain at least one element which is not present in A. So you see, it follows the same rule as proper set. Proper subset. If A equals to 1, 3, 5 and B equals to 1, 3, 4, 5, then there is an extra element which is 1, 4. So A is a proper superset of A, and we symbolize. But C equals to 1, 3, 5 is a superset of A. C is a superset of A because it contains another element of A. But obviously it is not a superset of A because C equals to A, and equal things cannot become a superset. So if I take these four symbols A, B and C and D, then you see that one is that B is the proper superset of A, but B is not equal to A because it has got an extra element. We write it as B superset of A. Second is that C is a superset of A, but the set C is not a proper superset of A. Why? Because C equals to A. You see, C and A are equal. So we can call it a superset, but it is not a proper superset because both of them are equal. D, again, it contains A, B, E, and it is not a superset of A, obviously because the elements are not matching. As I said, D does not contain the element E, which is present in D. We call D is not a superset of A. Okay. We use two types of superset symbols over here, and I would like to tell you. So this is something like A and B of any sets. B is contained in A. This is how it comes. And if A is not equal to B, then obviously it is a superset. Now, if a few or all the elements of set B are the elements of set A, then A is considered as a superset of B. Now, if we use this symbol, two symbols. One is this. It says that superset or equal to, or sometimes simply a superset, just like subset. Again, we use this symbol. It is superset of something. This means it represents strictly superset of, but again, it is not equal to. Same as subset. One is a proper subset and one is just a subset. This one has an equal to, and this has not got an equal to. Right? Okay, so let me show you an example. If I take X is a set of triangles and Y is a set of obtuse triangles, then obviously X is the superset of Y because obtuse triangles are classified under the types of triangles, and it can be denoted this. Now you see here is equal to. Why? Because obtuse triangles are equal to I would say a set of triangles. So improper subset is represented by this one, and this one is basically what we call proper subset is represented by this. So this is strictly not equal to, but this one is equal to. So that's it for today's video. We have got a total understanding of union, intersection, disjoint sets and a lot. I will continue with the next video a little bit more on the sets, because there are certain things like cardinality, etc., which I have not made, otherwise it would be in a very long video. Stay tuned for the next part of the sets, and then we will jump into the real numbers and we'll start with the real problem of analysis. Please do subscribe to my channel Physics for Students. Click on the bell icon to get all the notification from Physics for Students. And you can always contact me for any kind of a clarification. I'm available in this email ID. I have got a specialized channel for Einstein's general theory of relativity, which is this one. And further, you can follow me on my Instagram, Facebook and LinkedIn pages. Thank you very much for watching this video. Stay tuned on this series of reanalysis. We'll be completing sets and we will jump into the real problem of reanalysis with real numbers. Till then, goodbye and have a great day ahead.